Hello students, this is Indrani ma'am from Rasayan. In previous lecture, I have explained some exceptions on electron gain enthalpy. Link of that video will be given in the description box here. In this lecture, I will explain some more exceptions on electron gain enthalpy. In the previous lecture, we have seen in a periodic table along a period from left to right, size of the atoms decreases and negative value of electron gain enthalpy will increase. So, in a period, halogens are having highest negative electron gain enthalpy values. Now consider group 17, fluorine, chlorine, bromine, iodine, halogens. Down the group in the periodic table, since size of the atom increases, so addition of one electron will become less favorable because due to increased size, attraction between incoming electron and positively charged nucleus will decrease. Therefore, down the group, negative value should decrease. So, expected order for electron gain enthalpy should be like this. But actually, it is observed that in kilojoule per mole, chlorine is having minus 349, fluorine is having minus 328, bromine is having minus 325 and iodine is having this value. So actually Cl is having highest negative value, then fluorine, then bromine, then iodine. So here there is one exception. What's the reason for that exception? First you see all are having NS2 NP5 electronic configuration. So if you add one electron, what will happen? It will get nearest noble gas electronic configuration. So this is highly favorable process. That's why all values are negative. Addition of electron is highly favorable process. But we know fluorine is having very small size. So if you add one electron, there will be repulsion between internal electrons and added electron. So the process is not that much favorable. But in Cl, the size of Cl atom is larger than F. Therefore, here addition of one electron is much more favorable because repulsion is less. That's why this is having highest negative value, then this, then iodine. So you can note down this point. Then what is about electron affinity order? We know electron gain enthalpy is equal to minus electron affinity. Therefore, electron affinity means here values will be positive. So, decreasing order will be same only, but here no negative values. Here it will become positive. Only decreasing order will be here. Now say these are group 18 elements. These all are noble gases. Helium, neon, argon, krypton, xenon, radon. These are having valence shell electronic configuration. This means it is having fulfilled valence shell electronic configuration which is highly stable. So addition of one electron will destroy or will disturb this stability. Therefore the process is not favorable. So here suppose neon, addition of one electron is highly unfavorable. Highly unfavorable means it is having positive value. So neon is having kilojoule per mole, it is having this value. Then argon, krypton, these two are having same value. Xenon, radon. So the value is decreasing down the group because with increasing size, addition of one electron become less favorable. So the value will decrease. Now see, helium is having this value plus 48 kilojoule. Why this value is less than neon value? So here helium is having exceptionally small positive value because it is having very small size. So it is having high tendency to accept the electron. Therefore, it is having smallest positive value here. So this is one exception. From this value you can write the order. Neon is having highest, then this, then this, then xenon, then radon, and then helium, and this is due to this reason. We have seen Cl is having higher negative electron gain enthalpy than fluorine. Now concentrate on group 16. So down the group, electron gain enthalpy becomes less negative. But here also exception is there. In group 16, sulfur is having higher negative electron gain enthalpy than oxygen. In group 15, phosphorus is having negative electron gain enthalpy, and nitrogen is having, we have seen it is plus 31, it is having positive electron gain enthalpy. So what we have seen that here for period 3 elements there is high negative electron gain enthalpy than period 2 elements. Reason is same whatever we have discussed for F and Cl, fluorine and chlorine. Now what is the electron gain enthalpy order for group 16 element? For group 16, what is the order? Here sulfur is having highest negative electron gain enthalpy, then negative value is decreasing down the group, and oxygen is having less negative value. So this is the order. So this is important order, you have to remember this one. Now see here, which of the following will have the most negative electron gain enthalpy and which has the least negative value? 4 options are there. Now we have seen Cl is having most negative electron gain enthalpy. So here in each option Cl is there, so it should have most negative value. So maybe your answer 2, 3 or 4. Now which one is having least negative value? Now see, we have seen the electronic configuration of nitrogen, phosphorus, all are having stable valence shell electronic configuration. It is very difficult to add one electron. That's why for nitrogen, first electron gain enthalpy value is positive, and for phosphorus it is less negative than all those 3. So whatever it is given, less negative electron gain enthalpy, option 2 is not your answer, fluorine is not your answer, sulfur is not your answer will be 4. Phosphorus is having less negative value. Always remember group 16 is having less negative value than group 17. Group 15 is having less negative value than group 16. This is very important. Now see here, next question is arrange the correct electron gain enthalpy with negative sign order. Now whatever I told you, group 17 elements are having highest negative value than group 16, and group 16 are having higher negative value than group 15. So these two are group 16 elements and these two are group 17 elements. So between fluorine and chlorine we know Cl is having higher negative value, and since this is group 17 element fluorine, so next higher negative value is for fluorine. These two are group 16 elements, so these are having less negative value than group 17. So this is your order: chlorine, fluorine, sulfur, then oxygen. Negative value is decreasing in this direction. Similarly, if someone will ask you what is the electron gain enthalpy order of sulfur, oxygen, nitrogen and phosphorus. You know nitrogen is having positive electron gain enthalpy, phosphorus is having negative, but since these two are group 15 elements, these are having less negative value, and group 16 elements are having higher negative value. Now between sulfur and oxygen, which one is having higher negative value? Then phosphorus and then nitrogen. This is the order. Nitrogen and phosphorus all are having stable electronic configuration, and phosphorus is having negative value and nitrogen is having positive value. Reason is same, and whatever I told you for fluorine and chlorine. That's all for electron gain enthalpy. If you like, please subscribe. Thank you for watching.